Alright guys, today we're going to talk about the program development life cycle. Now before we talk about that, we need to first understand what is a computer program. You might have heard of this word before. Now it is a very simple definition. It's just basically a set of instructions carried out by a computer. Now what are some examples? Apps. Every app you see on your phone, on your computer, those are types of computer programs. They're simply a set of instructions that the computer carries out to perform a certain purpose, to meet a certain purpose. Now, a word that has the same meaning as the computer program is called the computer system. So these two words are interchangeable. So you need to remember that whenever you see the word computer system, it is the same as a computer program, and that is a set of instructions that a computer carries out. Now, there are 5 main parts that makes up a computer program. They are software, hardware, data, communications, and people. Now, you need to remember those. But for now, you don't really need to know about the details about what is the hardware, what is the software, and what is the data, communications, and the people, because we will talk about those in later chapters. So first, just keep in mind that a computer program is made up of these 5 things. So, all right. Now, let's see, how are computer programs created? Now, this will refer back to the chapter, the name of this chapter, which is the System Development Life Cycle. Computer programs are created through following this cycle. Now, when you see this big words in life cycle, you don't have no idea what the hell this means. Just take it easy. It is basically a set of instructions where this cycle is like different stages. You go through each stage, and at the end of this life cycle, you create a computer program. So there are 4 stages in this system development life cycle: analysis, design, coding, and testing. Now, there is no need for you to remember these stages. Just keep in mind that we use these stages and we go through each stage in order to create a computer program. Now, in this chapter, we're going to look specifically at the analysis and testing stage. These are 2 of the most important stages, and there will be some key concepts inside that you will need to remember. But for now, what you know is that a computer program is a set of instructions that the computer carries out, and an example are apps that you see every day. A computer program is the same as the computer system, and we used the system development life cycle to create computer programs, which is a set of stages that you go through. Okay, now let's take a look at the analysis stage. So the purpose of the analysis stage is to figure out the problem that the computer program needs to solve. So we know that the computer program, it can carry out a set of instructions, a set of instructions that the computer carries out, like apps. Now, this computer program, it solves a problem, right? It has a function, it does something. And the reason why it does something is because it solves a problem, it has a purpose. So first, we need to figure out what is the problem that the computer program solves. For example, I have a calculator. A calculator can be considered as a computer program. Now, the problem that the calculator solves is the problem that you need to, for example, add large numbers or multiply large numbers. So you have to figure out the problem first. After you figure out the problem that you need a computer program to solve, we then use this thing called decomposition. Now, this is a very, very important concept, and we will talk about this later on. But for now, just remember that we use this thing called decomposition in order to split the problem that we have figured out into smaller subproblems, right? And after we have split the big problem into smaller subproblems, we split them again into smaller subproblems. So you may not know what is going on right now. So let's take a look at an example. Let's say we have analyzed the problem that we need to add 2 numbers. This is the problem we need to solve using a computer program. Now, adding 2 numbers, how do we do that, right? This is the problem we need to solve. Now we split this problem into smaller subproblems. So here I split them into 3 problems. First, we need to input numbers. Second, we need to operate, so we need to add the 2 numbers together. And third, we need to output the answer or the sum of the 2 numbers. So here what we have done is we have split a big problem into 3 smaller problems. Now these smaller problems can actually be split into more problems. For example, in the input, now the problem is to input 2 numbers. Then we can split it into input number 1, and we input number 2. So we input 2 numbers. So what we have done here is essentially we have split the problem we have it initially, which is we need to add 2 numbers, into 3 smaller problems. And then we can split these smaller problems again into smaller problems until we cannot split them anymore. After we cannot split them anymore, it is very, very easy to solve each function. All right. Now, there is a different interpretation for what we have just done here. So what we just done here was splitting the problem into smaller problems. But if you think about it, a problem is solved by a computer system, right? So each of these functions or each of these problems are actually solved by a computer system, a computer program. This big problem is solved by a computer program. These smaller problems are solved by computer programs. Even the smallest things at the bottom are solved by computer programs. Therefore, what we can say is that this entire thing is a large computer program, right? Because because we're trying to develop a computer program to add together 2 numbers. This large thing is a computer program. But this computer program can be split into smaller computer programs. And these computer programs include input, operation, output. And we can split the input, this small computer program, into even smaller computer programs. So the official definition of decomposition is the splitting of a computer system into smaller subsystems, which can in turn be split into smaller subsystems. Now, this definition is very, very important, right? So please make sure to memorize this definition because it is likely that it will appear in exams. But for example, let's just look at the example we had before of adding together 2 numbers. The initial large computer system or the computer program is used to add together 2 numbers. This computer system can be split into input, operation, and output, because these are the 3 functions that make up this computer program. If we take away input, then this program will not work. Only with these 3 subsystems will this program work. And this input can again be split into smaller subsystems. Operation can be split again into subsystems. So what we can say is that actually a computer system is made up of smaller subsystems. Okay? So that is decomposition. All right. Now let's look at the testing stage. After we have done the analysis stage, now let's look at the testing stage. These are the 2 most important stages in the system development life cycle. And the purpose of this testing stage, so why do we even need it, is because we need to make sure the program we have just written or the computer system actually works. So you have written lots of code, you have made a computer program that is able to add together 2 numbers. Then how do you know it works? How do you know that you can actually add 2 numbers? Now we need to use the testing stage to test the computer system and make sure that it works. Now, how do we test it? We test the computer system by entering data into the system and seeing if if the results are correct. So we enter different types of data into the system and see if it works. For example, if we have a computer system that adds together 2 numbers, right? Then we can pass 2 numbers into it. 1 and 2, and see if the output, or see if the computer program will give us the result of 3. Then we can pass maybe 5 and 10 inside and see if the result is 15. This is essentially what is happening in the testing stage. However, simply passing these data is not enough to make sure that the program fully works. And now I will show you why. There are 3 main types of test data. There are normal data, abnormal data, and boundary data. Now, normal data is correct and acceptable data. It's the data that we just see. But we'll talk about this later. First, let's talk about these 3 types of data. We need to use all 3 types of data, and we enter these data into a computer program to make sure that the program works. First is normal data. It is the correct and acceptable data. Abnormal data is incorrect and unacceptable data, and boundary data is data that is on the edge of being acceptable and unacceptable. Now, you might not know what they mean right now, but let's just look at an example, and you will fully understand. So now, let's say that we have just made a computer system that can add together 2 numbers that are in the range from 0 to 100 inclusive. All right? This is our computer system. It can add together 2 numbers from 0 to 100. So a set of normal data that we can give the computer system to test that it works is, for example, we can 2 and 5. We can give it the pair of 2 and 5. If we pass the pair of 2 and 5 inside, they are normal data because it is correct. It is in the range of 0 to 100. It is part of this range, right? So it is correct and acceptable data. How about abnormal data? Abnormal data are incorrect and unacceptable data. Now, if we pass together, for example, a set of numbers like -10 and 200, this is a set of abnormal data. We have to see if the computer system recognizes that this set of data does not work, so that is out of the bounds and it is incorrect. We need to see if the computer system can still run if incorrect or abnormal data is entered. So the first type is normal data that is correct and acceptable, and second is abnormal data. And the reason why this is abnormal because, see, the computer system only accepts numbers from the range of 0 to 100. Now this -10 is below 0, and this 200 is over 100. Therefore, we can say that it is part of abnormal data. The third is boundary data. Now, the definition says that it is on the edge of being acceptable and unacceptable. What this means is that, for example, in this range from 0 to 100, boundary data, for example, can be 100 because it is on the edge of being acceptable. How about on the edge of being unacceptable? Maybe it is 101. That can actually be considered as boundary data. How about 0 and -1? These are all types of boundary data. We need to make sure that the computer system works for all these 3 types of data in order to make sure that it works. So this is the types of testing data that we enter into the computer system to make sure that it works. All right, that is the end of today's lesson. Stay safe. Peace. See you next time.